For thousands of years, humanity has sought to understand reality. What is matter? What is space? What is time? The deeper science has explored these questions, the stranger reality has become. Matter appears solid, yet atoms are mostly empty space. Particles behave like waves. Time can slow down. Space can bend. The universe expands, and some objects are so extreme that not even light can escape them. Modern science has transformed our understanding of nature, yet it has also revealed profound mysteries. Mysteries that continue to challenge our deepest assumptions about reality itself. The atom. Everything around us is made of atoms. At the center of every atom lies a tiny nucleus. Surrounding it are electrons. Yet the atom is almost entirely empty space. If the nucleus were the size of a marble at the center of a stadium, the electrons would occupy the outer edges. Everything in between would be almost empty. The atom is not mostly matter. It is mostly emptiness. Yet somehow, this emptiness gives rise to the solid world around us. Why? The quantum essence of matter. Deep within the atom, reality becomes stranger still. In the famous double-slit experiment, particles behave as though they pass through multiple paths at once. Yet when observed, they appear to choose a single path. Quantum theory suggests that particles may exist as possibilities before measurement, and particles can become entangled, remaining mysteriously connected even across vast distances. Quantum mechanics predicts these phenomena with extraordinary accuracy, yet their deeper meaning remains one of science's greatest mysteries. The mystery of energy. Energy powers stars, planets, machines, and life itself. We can measure it, transform it, harness it. Yet, what exactly is energy? In nuclear reactions, tiny amounts of mass can become enormous amounts of energy. Matter and energy appear deeply connected. But why? What is really being transformed? The expanding universe. Modern astronomy revealed that the universe is expanding. Galaxies are moving apart. Space itself is growing. Tracing this process backward suggests that the universe once existed in an extraordinarily dense state. The Big Bang. Yet the mystery deepens. The expansion appears to be accelerating. Something seems to be driving the universe outward. What is it? Gravity and magnetism. Gravity shapes the universe. It binds planets, stars, and galaxies together. For centuries, one question remained. How can one object affect another across vast distances? Einstein showed that gravity is connected to the very fabric of space and time themselves. Magnetism is equally remarkable. Invisible fields can attract and repel across empty space. Both phenomena are described by science with extraordinary precision. Yet a deeper question remains. What is it that truly connects one object to another? The speed of light. Nothing with mass has ever been observed to travel faster than light. The speed of light appears to be a fundamental limit of reality. Yet something even stranger occurs. Every observer measures light traveling at exactly the same speed. No matter how fast they are moving or in which direction they are moving. This discovery transformed physics. But why should the universe behave this way? Time. Time appears constant, yet modern physics revealed otherwise. Clocks moving at high speed run more slowly. Clocks near powerful gravitational fields also run more slowly. Time itself changes. This is not theory. It has been confirmed repeatedly by experiment. But what exactly is time? And why should motion and gravity affect it? Black holes. Among the strangest objects in the universe are black holes. Regions where gravity becomes so intense that not even light can escape. Near a black hole, space and time themselves appear profoundly distorted. Black holes sit at the intersection of many of the deepest mysteries in science. Gravity, quantum mechanics, space, time, matter itself. They may offer a glimpse into some of the deepest structures underlying reality. A different way of looking at reality. We have encountered a remarkable collection of mysteries. The atom, quantum mechanics, energy, gravity, light, time, black holes, the expanding universe. Modern physics describes these phenomena with extraordinary accuracy. Yet a question remains. Are these truly separate mysteries? Or are they different expressions of a deeper underlying reality? The framework explored in this film begins with a simple proposition. Reality is not fundamentally composed of separate things. Beneath the diversity of existence lies a deeper relational unity, a reality shaped by two opposing tendencies, differentiation and unity. Differentiation gives rise to distinct objects, structures, and forms. Unity is the tendency of reality toward convergence. Every part of existence participates in a universal tendency toward every other part of existence. Taken to its ultimate limit, this convergence would compress reality toward an infinitely small, singular state. Initially, this idea may sound unfamiliar. Yet from this single principle, a surprising number of physical phenomena begin to reveal a common pattern. Let us begin where matter itself begins, at the heart of the atom. Convergence and the atom. Everything in reality, matter, energy, and even space itself, participates in a universal tendency toward convergence, a tendency toward deeper relational unity. Why then does everything not simply collapse together? Because these converging influences ordinarily balance one another from every direction. Like atmospheric pressure acting equally from all sides, the forces largely cancel out. But extremely close to the atomic nucleus, that balance changes. There is little room for surrounding influences to act between a particle and the nucleus itself. The nucleus blocks them from one side. The balance is lost. As a result, powerful short-range attraction emerges. Within this framework, the binding of the nucleus is a local manifestation of the same universal tendency toward convergence and compression that operates throughout reality. Quantum reality and singular unity. If convergence exists, toward what does it converge? The answer is singular unity, a state in which all distinctions collapse into a oneness, a point, a singularity of infinitely small dimension, a state in which separation and even space itself cease to exist as differentiated realities. If reality possesses such an underlying unity, many features of quantum mechanics become easier to conceptualize. Particles are never completely separated from the deeper singular unity that underlies differentiated existence. This gives reality a capacity, in a sense, to be everywhere at once. Not because particles travel everywhere, but because all locations participate in the same, deeper, singular reality. Entanglement reflects the same principle. What appears separate remains connected beneath the surface. Distance exists within differentiated reality, yet beneath that differentiation lies a deeper unity that continues to bind all things together. The electron cloud. This same principle illuminates one of the strangest features of the atom, the electron cloud. If the nucleus participates in deeper singular unity, its presence is not confined entirely to a single point. Its quantum capacity to participate in many locations simultaneously represents an extension beyond the physical nucleus itself. But the nucleus is not alone. The rest of reality participates in the same tendency. Everything seeks both relational extension and convergence. A balance ultimately emerges. The nucleus pushes outward through its relational presence. The surrounding reality constrains that outward extension through universal convergence. The electron cloud represents the boundary between these opposing tendencies. The electron shells are the visible expression of that equilibrium. The atom itself becomes a remarkable balance between unity and differentiation, a tiny reflection of the deeper structure of reality. Gravity, magnetism, and time. The same principle illuminates gravity. Gravity is the physical expression of increasing relational unity between objects. Every object in reality participates in a universal tendency toward convergence with every other object. Ordinarily, these converging influences balance one another from all directions. But near a massive body, that balance becomes uneven. The nearby object participates far more strongly in relational unity with the larger mass than with the more distant universe surrounding it. The result is a net tendency toward convergence. This is experienced as gravitational attraction. Gravity is therefore not simply a force acting between objects. It is the visible expression of an increasing degree of shared existence. Magnetism may reflect a similar pattern. When magnetized objects touch, their aligned structures bind together through electron interactions. Within the framework proposed here, that connection does not disappear when the objects are separated. Through their participation in relational unity, it is as though they continually are being joined together and then apart once more. This continual tendency toward reconnection produces an overall attraction. We experience that pull as magnetism. Time is also affected by these same processes. We have seen that time slows near strong gravitational fields and during acceleration. Within the proposed architecture of reality, increasing convergence draws an object toward a more unified relationship with the reality toward which it is moving. The larger mass experiences a slower rate of change, a slower aging than the smaller object. As relational unity between them increases, the smaller object increasingly shares in that slower aging. This is experienced as a slowing of time. Gravity, motion, and time are therefore not separate phenomena. They are different expressions of the same underlying movement between differentiation and unity. The expanding universe revisited. If unity within a single point, the singularity, represents one aspect of reality, differentiation represents the other. But distinct objects require separation. They require extension. They require space. Differentiated existence, therefore, implicitly involves both expansion and acceleration. The Big Bang represents the earliest stage of this process. The universe emerges from an extremely unified condition and unfolds into increasingly differentiated forms. Matter forms, structures emerge, galaxies develop, complexity increases. Expansion is not merely something that happens within reality, it is part of what differentiated reality is. The accelerating expansion of the universe reflects the continuing emergence of differentiation from underlying infinitely compressed unity. Reality simultaneously expresses both tendencies, the tendency toward convergence to infinitely compressed unity and the tendency toward differentiation. The history of the universe is the unfolding relationship between the two. Motion, inertia, and the speed of light. Motion also takes on a deeper meaning. To move in one direction is, in part, to separate from the reality that lies in the opposite direction. If reality possesses a universal tendency toward unity, such separation naturally encounters resistance. That resistance is experienced as inertia. Mass reflects the degree to which an object resists separation from its relational unity with surrounding reality. The more deeply an object participates in those relationships, the more difficult it becomes to alter its motion. The same principle gives rise to the universal speed limit. As velocity increases, separation from surrounding reality increases. This increasingly conflicts with reality's tendency toward integrated unity. So, the resistance grows. The closer an object approaches the speed of light, the greater that resistance becomes. An ultimate boundary is approached, the speed of light. This same framework also illuminates one of the most remarkable discoveries in modern physics. Every observer measures the same speed of light. Ordinarily, this appears deeply counterintuitive. But if every observer remains fundamentally connected to the rest of reality through relational unity, then no observer ever becomes completely independent of that shared framework. Each observer, even if moving, remains fundamentally anchored. Light, by contrast, is not constrained by matter in the same way. The result is that every observer experiences light as possessing the same constant speed. Inertia, mass, the speed limit of the universe, and the constancy of light all emerge from the same underlying principle of relational unity. Black holes revisited. Ordinary matter possesses an internal coherence that resists universal convergence and compression. The atom itself is an expression of this resistance. Its structure preserves differentiation while existing within a reality that continually tends toward compressed unity. But within the remnants of a massive collapsing star, a different condition emerges. The ability of the star's internal structure to resist convergence weakens dramatically, yet it does not disappear entirely. If that resistance vanished completely, total collapse into singularity would occur. Instead, the object enters a unique intermediate state, a continual struggle between coherence and collapse, between structure and convergence. But unlike ordinary matter, the object no longer fully resists penetration. Thus, anything entering this region becomes increasingly subject to the same overwhelming convergent tendency. This is experienced as the immense gravitational influence associated with a black hole. The black hole, therefore, represents a region where reality approaches the limits of coherence without fully surrendering to singularity, a state balanced between differentiated existence and complete collapse. Energy revisited. What then is energy? Within this framework, energy is the visible expression of reality reorganizing itself. Consider a nuclear reaction. A portion of mass disappears. The structure that previously occupied that region of reality is no longer present. A void is created. Not empty space in the ordinary sense, but a gap within an existing relational structure. Earlier, we saw that the apparent emptiness within the atom reflects a balance between the outward relational presence of the nucleus and the converging tendency of surrounding reality. When nuclear mass collapses or disappears, that balance is suddenly disrupted. Universal reality is no longer restrained. The converging tendency rushes to occupy the newly available relational space. An analogy may help. When a deep-sea vessel implodes, the surrounding ocean rushes inward almost instantly to fill the void. The resulting collapse releases enormous energy. Within this framework, something conceptually similar occurs in nuclear reactions. Reality rapidly restructures itself. A new equilibrium is established. The resulting restructuring is experienced as released energy. Energy is therefore the visible expression of reality seeking balance toward a unified theory of reality. Atoms, quantum mechanics, gravity, time, expansion, light, black holes, energy. These are not separate mysteries. They are different expressions of one underlying reality. A reality shaped by the interaction of unity and differentiation, convergence and extension, singularity and structure. The same principles that govern the atom also govern the cosmos. The same tension that shapes quantum behavior also shapes gravity, motion, energy, and the evolution of the universe itself. Within this framework, the diversity of physical phenomena emerges from a single underlying architecture. Reality is not a collection of disconnected mechanisms. It is one coherent structure expressing itself in different ways at different scales. Whether this framework ultimately proves correct remains to be seen, but it offers a unified conceptual lens through which many of the deepest mysteries of physics may be understood as parts of a single interconnected reality. Beyond the scope of this film, in the nature of things, this film has explored only part of the broader framework. Even within the areas discussed, many details have necessarily been simplified. And some of the most profound questions lie beyond the scope of this film entirely. Most notably, questions concerning electron orbitals, time and movement, gravity and acceleration equivalence, and of course, human consciousness itself and its effect on matter. These subjects are explored further and in greater depth in the accompanying book, Beyond Matter, upon which this film is based. Yet before we conclude, one final question remains. Indeed, perhaps the deepest question of all. If reality possesses a universal tendency toward convergence and unity, what in actual fact is the source of that tendency? Why should reality behave this way at all? Why should existence display any drive towards singularity and compression in the first place? To answer that question, we must move beyond physics itself into the realm of ontological speculation, the study of existence itself. The infinite beyond. What is the source of convergence? Why should reality tend toward singular unity at all? One possible answer could lie beyond the universe itself. Suppose that ultimate reality exists beyond the observable universe, and suppose that it is truly infinite. Not merely infinite in size, but infinite in significance, depth, and fullness of being. Relative to such an infinity, finite reality may possess only the faintest degree of independent existence. From that perspective, the tendency toward unity and singularity may be understood as the natural consequence of finite reality being exposed in some way to the infinite. Not because matter is physically forced together, but because all finite differentiation becomes infinitely small when set against true infinity. The tendency toward convergence would then reflect something deeper than physics. It would reflect the ontological relationship between finite existence and the infinite beyond. This idea extends beyond the boundaries of science. It enters the domains of philosophy, ontology, metaphysics, and even theology. It remains speculative. Perhaps the mysteries of physics are ultimately not only questions about matter and energy, but questions about existence itself. These questions remain open, and humanity's search for answers continues.